This is a final video presentation of recently completed ESTCP project ER20-5088 entitled PFAS Leaching at AFFF-Impacted Sites, Insight into Soil and Groundwater Ratios. The project team for this project at CDM Smith includes myself, Charles Schaefer, Zoom Nguyen, Dr. Ida Fang, and Max Heyer, and at the Colorado School of Mines, Dr. Christopher Higgins, Dr. Tisa Ilangasakari, Dr. Stephanie Shea, and Dr. Chuwei Zhang. The overall goal for this project is to demonstrate improved insight into PFAS leaching through the unsaturated zone, with the intent of having this information serve as a basis for developing soil cleanup criteria. Specifically, we wanted to evaluate and verify methods for measuring PFAS concentrations in soil pore water. We want to be able to assess the different site conditions and how they might impact PFAS leaching and essentially the concentrations of PFAS in pore water. And we also wanted to evaluate the role of PFAS absorption at the air-water interface on leaching, specifically in situ. For this project, we focused primarily on 5 sites, and these were sites that were former AFFF impacted areas. For most of these sites, it has been several years to decades since any last known exposure to AFFF. And this table, again, just summarizes some of the key properties and information at each of these sites. So at each of these 5 sets, we worked primarily in a very small cluster within essentially a 5-foot by 5-foot footprint. We collected intact soil cores for PFAS analysis as a function of depth. We also collected information on cation exchange capacity, soil TOC, look for VOCs, as well as some general properties such as soil grain size, pH, and moisture content. We collected some intact cores for lab testing. We'll talk about this on the next slide. We did some pore water extraction using what I term microlysimeters for some of these cores. Also for one depth location, and this was the depth location that was essentially the same as the depth of the lysimeter. We did a more thorough PFAS analysis looking at both target and suspect analytes. We also did a desorption kinetic test in a soil slurry with about a 3-to-1 liquid to solid ratio. And again, at the site inside that small 5-by-5 footprint, if you will, we installed a cluster of 3 lysimeters. Typically, we would have an initial purge and then collected 2 to 3 rounds of samples for PFAS analysis. If there was sufficient water, we also looked at the TOC, pH, and connectivity and anions in the pore water. For one of the sites, Site D, we actually went out 2 different times and installed and sampled lysimeters, one time during, there were some heavy rains, another time during a more dry period. Bit of more information in terms of what we did for our field lysimeter collections. There's an illustration on the left-hand side of how the lysimeters were installed and the vacuum that was pulled, typically around 60 or 65 centibar. On the right is how we did the bench scale microlysimeter pore sampling. Typically, we consider this a more equilibrated sample as opposed to maybe the somewhat dynamic conditions in the field. Typically, samples were equilibrated 3 days. Now, ideally, at the bench scale, as you see in the kind of the bottom middle picture there, we would collect a sample on an intact core. In practice, for several of the soils, this was too difficult. The soils were either too dry or they crumbled. So what we essentially did was repack the soil, and in some cases added a little bit of moisture as well to help facilitate pore water extraction. So just a real quick summary of what we did. Here are results for a couple of sites where we have our in situ field lysimeters with the blue bars compared to what we measured in the collected cores in the laboratory. And what you see within essentially the uncertainty of our measurement is we get pretty reasonable agreement for most compounds within a factor of 2.5 or so, which really tells us in the field samples using an apparent equilibrium assumption is probably very reasonable. So this was certainly reassuring and gave us some confidence in what we were measuring with our field lysimeters. There was one site where we did not have good agreement between what we measured in situ and what we measured in the pore water in the collected core. In many cases, we were seeing 1 to 2 orders of magnitude higher concentration in the bench scale collected pore water than in the field. While we don't have a very good explanation for this, we do know that the soil here had been previously excavated, thermally treated to remove petroleum hydrocarbons, and then put back in the excavated space. Some GPR work that was done at the site showed that there were a lot of anomalies in the soil. So this seems to be a bit of an outlier and not all completely intact native soil in this location. Maybe this has something to do with the discrepancy. At the very least, I think it should tell us that we should view lysimeter data perhaps with caution in similarly types of excavated and then reapplied soils. Finally, what we have shown here is, again, a plot of the various PFAS concentrations. And in this case, we're comparing what we measured in the field lysimeters to what we measured in those batch soil slurries with about a 3-to-1 liquid to solid ratio. In this case, for many of the shorter chain compounds, what we found was the expected case that concentrations were much higher in the field as we were getting some expected dilution in those batch slurries. But for some of the more surface active compounds, for example, PFOS and A2FTS, we saw about an order of magnitude higher concentration in these batch slurries. And the reason we think this is happening is because of collapse of air-water interfaces, and that mass was released, and there was enough mass there that we actually, under saturated conditions, even with the types of dilutions you get in a batch soil slurry, we saw much higher concentrations. This result is interesting, and I think may point to the fact that we should any sort of batch slurry leaching test results should be viewed with caution, as this does not account for PFAS accumulation at the air-water interface and any impact that might have on leaching. I just want to conclude by just noting the manuscript noted in the lower left-hand corner here, and these results presented in much greater detail for these 5 sites is presented in the Journal Contaminant Hydrology publication, and you can feel free to look at that paper for further insight. Thank you very much for your time.